What if I told you that computers can be just as biased, immoral, and blatantly inaccurate as humans? While it may seem that computer algorithms, due to their seemingly objective nature, are good tools to eliminate human error and bias from situations ranging from deciding trial verdicts to presenting search engine results, this may not necessarily be the case. Algorithmic bias refers to human bias that is ingrained within and perpetuated by algorithms. Biases can make their way into models through a variety of means, one of which being biased data for model training. If there's perhaps more data available for particular outcomes than others, a model may mistakenly overestimate the likelihood of particular situations. Even in training data that has an equal number of occurrences for all possible outcomes, the outcomes of the data themselves may be based off biases. For example, it is possible that an algorithm may overweight the likelihood that a person of a particular race will recommit a crime because of racial biases and convictions. As a result, the model trained by this data would make suggestions based off the racial biases its training data reflects. The COMPASS algorithm is a good example of such algorithmic bias. This black box algorithm has been used in U.S. courts since the year 2000 to give recidivism scores for convicts. In 2018, a ProPublica investigation revealed that the algorithm guessed incorrectly about twice as often for black individuals as it did for white individuals. Instead of providing judges with objective data, COMPASS perpetuated the already existing racial biases seen in U.S. courts. It should be noted that algorithmic bias is not an easy fix solution and is actually extremely difficult to remove from the algorithms we see used in everyday life. In the case of COMPASS, researchers at Dartmouth were actually unable to increase the accuracy of the algorithm after many attempts and even realized the conclusion that it is mathematically impossible for the algorithm to be completely fair.
Even large tech giants struggle with algorithmic bias. As mentioned in a recent article in Forbes magazine, the MIT Media Lab revealed that Amazon's facial recognition software underperformed in identifying darker-skinned individuals, as well as women of all races. To make matters worse, these tech giants are not recalling their products to improve algorithmic impartiality, perhaps due to misaligned motives involving profit. In the case of Amazon, despite Recognition's reported biased performance, Amazon continues to push its software to law enforcement and the military. If the facial recognition software continues to be used in the state, it could perpetuate biases and general incompetence in law enforcement and the military, potentially even endangering lives. In an effort led by the AI Now Institute, experts from legal, scientific, and technical backgrounds gathered to discuss challenges across 5 areas of government where algorithmic decision-making is already in use. These areas were Medicaid and government benefits, public teacher employment evaluations, the role of social science and technical experts, criminal risk assessment, and criminal DNA analysis. The researchers found examples where these systems were used to save costs or to streamline work without any assessments of how they might disproportionately harm the most vulnerable populations they are meant to serve. Furthermore, it was seen that numerous government agencies that switched from human-driven to algorithmic decision-making did not prioritize the retention of fairness and due process in making the switch. The effects of algorithmic bias are seen in other areas of our everyday lives. Take the example of YouTube and its Up Next recommendation system, which identifies videos that you may like based on your current video. According to former YouTube engineer and artificial intelligence PhD Guilherme Cheslot, YouTube's algorithm optimizes solely on the number of minutes watched before clicking away, and quote, everything else was considered a distraction.
Such a decision has disturbing side effects. Just a couple of years ago, examples of videos that often show up in the Up Next recommendation section included videos of Logan Paul stumbling across a dead body, conspiracy theories on the Las Vegas shootings, Peppa Pig eating her father or drinking bleach, offensive claims about Michelle Obama or the Pope, and the Flat Earth theory. In summary, the YouTube Up Next recommendation algorithm has a bias that manifests itself in favoring disturbing, controversial, violent, inflammatory, or misinformed content because it might generate more clicks. YouTube's response has been to recruit more human moderators and shut down offensive videos and channels, but this does not solve the root of the problem. An extremely important consequence of YouTube's algorithmic bias is its potential effect on the 2016 election. To investigate this potential effect, Cheslot developed a program that started from a seed video found from a fixed search query and then traversed the tree of Up Next recommendations. When he applied his program to keywords like Clinton and Trump, he came to the shocking conclusion that about 86% of partisan videos favored Trump while about 14% favored Clinton. Scrutinizing the individual videos, Cheslot found that most of the videos favoring Trump actually featured anti-Hillary conspiracy theories or other defamatory content, which YouTube's algorithm favors. The chilling lesson is that on YouTube, spouting lies and controversy actually seems to win. These videos are more frequently recommended by YouTube to viewers, giving them more views, in turn making YouTube's algorithm recommend them with higher frequency. These examples teach us an important lesson. We must understand that algorithmic objectivity is in reality extremely difficult to achieve and must be tested thoroughly rather than simply assumed. It's important that we use multidisciplinary approaches to address these issues and that people from a wide variety of backgrounds are involved so that we do not continue to reinforce one-sided biases.